Right now, 3I/Atlas, a visitor racing at nearly 96,000 kilometers per hour through the inner solar system, casts a ghost-like silhouette across the Martian dawn. At Gale Crater, Curiosity's high-resolution mass cameras capture an image so sharp that individual dust grains illuminated by the comet's coma can be distinguished. The data appears ordinary at first glance, until spectral readings reveal structures no comet from interstellar space has ever displayed. Something about 3I/Atlas is rewriting the rules of what a wandering object can be. At a distance of only a few million kilometers from Mars, an object the size of a small mountain cuts across the darkness at more than 96,000 kilometers per hour. Its halo glows in shifting shades of green, illuminated by the sun's radiation as it slants past the orbit of the red planet. This is 3I/Atlas, the third confirmed interstellar object to enter the solar system, and the first ever witness from the surface of another world. Against the rust-colored horizon of Gale Crater, Curiosity's instruments lock onto the distant apparition, gathering photons that have traveled across the void for an instant and across the galaxy for an eternity. Interstellar visitors are rare, and each one challenges expectations. Oumuamua's tumbling acceleration defied standard cometary physics. 2I/Borisov resembled a more familiar icy body, yet carried chemical signatures from beyond any known stellar nursery. But 3I/Atlas is different. Its trajectory is pristine, a near-perfect hyperbola, as though sculpted by gravitational influences long vanished. The rover's cameras capture its emerald coma, a glow produced by diatomic carbon fluorescing in the cold emptiness of interplanetary space. And yet the light flickers, not randomly, not chaotically, but in intervals precise enough to raise questions before the data even finishes transmitting. Curiosity stabilizes its mast as dust devils drift across the crater floor, its optics compensating for atmospheric haze. The image that emerges is brighter and sharper than astronomers expected, revealing patterns hidden within the comet's glow. The brightness curve pulses in steady, repeating rhythms that mimic engineering more than nature. Each cycle follows an almost metronomic regularity, deviating by only fractions of a percent. Spectral overlays show symmetrical jets of gas erupting from the nucleus, forming a radial geometry no known comet has ever displayed. On Earth, observatories shift their focus toward Mars, but none can match Curiosity's angle of observation. Mars sits in the one position in the solar system that aligns perfectly with the comet's trajectory, granting the rover a privileged view unavailable from Earth or orbiting spacecraft. As the raw data begins its journey across deep space relay networks, scientists prepare for another interstellar curiosity. What they receive instead is unprecedented clarity, the most detailed image of an alien comet ever recorded. Analysts notice strange consistencies, jets emerging from opposing points, light patterns forming near geometric shapes, and thermal fluctuations rising and falling in smooth, controlled arcs. Models fail to replicate the symmetry. The jets should be random, governed by uneven pockets of volatile ice buried within the nucleus. But these emissions behave as though arranged by some underlying blueprint. Across laboratories and control rooms, speculation grows. Could extreme conditions in another stellar system produce such ordered behavior? Could unknown physical processes shape a comet into such regular patterns? Or is 3I/Atlas carrying the structural imprint of forces far older and far stranger than anything formed within the sun's gravitational reach? A question begins to form, subtle yet unavoidable, as researchers sift through the early data. If these structures aren't accidental, then what shaped them, and how long have they been traveling between the stars? A thin veil of Martian dust drifts across the sky as Curiosity angles its mass toward a point of pale green light moving rapidly above the horizon. At nearly 96,000 kilometers per hour, 3I/Atlas is a challenge even for terrestrial observatories, but for Mars, under a thinner atmosphere and a darker sky, the comet becomes a luminous thread etched against the void. The rover's optics lock on, pixels stabilize, and a moment later, an impossible image forms. The nucleus comes into view with crystalline clarity. Instead of the rough, chaotically carved contours typical of frozen volatiles sublimating under sunlight, the surface of 3I/Atlas reveals sharply defined facets, planes and angular ridges that stretch for tens of meters, reflecting sunlight in narrow, consistent bands. The geometry is unsettling in its precision. It resembles mineral lattice structures, but on a scale that defies conventional comet formation. Each edge seems too clean, each angle too deliberate. Curiosity spectrometers, designed primarily for Martian geology, analyze the faint sunlight reflected from the moving object. The readings return unfamiliar chemical signatures, exotic carbon chains that fracture at anomalously low temperatures, behaving more like engineered polymers than simple cosmic ices. These compounds appear resistant to thermal stress, yet prone to rapid photodissociation, properties unlike any known interstellar material. Something about their behavior suggests a fabrication process not seen in natural astrophysical environments. Mission Control receives the data and begins reconstructing the image using advanced AI enhancement. Algorithms clarify grain boundaries in the comet's surface, unearthing patterns invisible to raw optics. Beneath the crystalline shell lies a sequence of layered strata, each tilted at a consistent angle relative to the comet's axis. The layers form a spiraling architecture, an ordered internal arrangement that grows tighter toward the core, as though shaped by rotational dynamics under conditions alien to conventional astrophysics. No known process in planetary disks, molecular clouds, or cometary nurseries produces such symmetrical internal structure. As scientists examine the enhanced renderings, they confront deeper questions. Could such a formation arise from the slow accumulation of exotic interstellar materials over millions of years? Could radiation fields or long-duration particle bombardment carve order into chaos? Or does the structure hint at processes not described in current models? Processes involving pressures, temperatures, or electromagnetic environments that do not exist near the sun. The image spreads across laboratories around the world. Experts in crystallography, comet physics, and extraterrestrial mineralogy pore over each facet. Some note that the reflective bands echo patterns found in quasicrystals, materials that obey mathematical symmetry without repeating. Others observe that the spiraling interior resembles growth structures found in biological systems, though on a vastly larger, inorganic scale. The interpretations vary, but all share a common thread. 3I/Atlas is not behaving like an ordinary comet. It is something stranger, something that seems to carry a history written in its structure. The rover's image becomes more than a scientific achievement. It becomes a riddle, a quiet question embedded in the icy geometry of an interstellar traveler. If 3I/Atlas was shaped in an environment unlike any known star system, what kind of birthplace could produce such disciplined patterns? Across the thin Martian atmosphere, curiosity observes the distant silhouette of 3I/Atlas rotating through space, and at regular 43-minute intervals, something extraordinary breaks the stillness. A plume erupts, narrow, brilliant, and astonishingly consistent. Then another, and another. Each jet fires with a precision more familiar in mechanical systems than in drifting cosmic ice. Even from millions of kilometers away, the timing is unmistakable. The gaps between eruptions vary by only a few milliseconds, a stability far beyond the chaotic rhythms that govern ordinary cometary outgassing. Most comets are shaped by randomness. Sunlight strikes uneven surfaces, pockets of volatile compounds heat at unpredictable rates, and jets burst forth in messy asymmetry. But 3I/Atlas is different. Its jets erupt from fixed points arranged almost symmetrically along its surface. Curiosity's time-lapse images reveal that each plume originates from an aligned position, as though the nucleus contains internal conduits, chambers oriented along a precise geometric grid. The rotational axis itself appears remarkably stable, maintaining its orientation even as solar radiation pushes against the comet's surface. Nothing about its behavior suggests the disorder expected from a natural object. Spectroscopy deepens the mystery. The jets contain complex nitrides and silicon-bearing particulates, compounds rarely found in cometary environments, combined with carbon chains so reactive that many disintegrate before reaching the rover sensors. Their composition suggests pressures and temperatures within the nucleus that should fracture even the densest cometary core. Yet 3I/Atlas shows no signs of structural stress. Instead, it remains intact, as though designed to withstand internal eruptions far more powerful than any produced by solar heating alone. Computational models attempt to reproduce the timing, the chemical composition, and the symmetry of the plumes. None succeed. If sunlight alone triggered the jets, they would vary as the comet approached perihelion. If internal volatiles were distributed irregularly, as they always are in natural comets, the eruptions would shift, fade, or intensify unpredictably. But the 43-minute cycle remains constant, immune to distance, angle, and solar flux. The pattern holds as though governed by an internal mechanism, one hidden beneath layers of crystalline architecture. Planetary scientists propose unconventional origins. Perhaps the comet passed through an interstellar shock front that carved channels within its core. Perhaps its rotational symmetry is a remnant of formation in an unusually quiet molecular cloud. But these theories strain credibility. No environmental process, no matter how exotic, would produce such disciplined, repetitive behavior. The comet acts less like a volatile rich body venting gas and more like a system releasing energy on schedule. As Curiosity continues observing, the jets begin to form subtle variations. Tiny modulations in brightness, microsecond shifts in onset, faint spectral changes that appear in repeated sequences. Analysts map these variations and discover recurring patterns embedded in the timing. They resemble structured pulses rather than natural plumes, as though the comet is emitting information through light, dust, and gas. Not random, not chaotic, intentionally patterned. The data forces a profound question. If these eruptions resemble signals, then the comet is not merely venting. It is communicating through intervals and intensity, through chemistry and rhythm. 37,000 kilometers beyond the Martian horizon, the faint arc of 3I/Atlas drifts through Curiosity's field of view, an object carrying a velocity so high and a trajectory so precise that its path stretches far beyond the boundaries of any known stellar nursery. Its path is not merely interstellar. It is intergenerational, a voyage measured not in millennia, but in epochs. Astronomers trace that path backward, plotting the faint gravitational fingerprints it must have endured, and they find a story stranger and older than anything ever recorded in the catalog of wandering bodies. The comet's hyperbolic orbit indicates no recent expulsion from a young system. Instead, the numbers point toward the galactic halo, where ancient stars once burned with weak metallicity and slow, aching luminosity. Somewhere in that sparse region, long before the sun existed, a dying red giant may have collapsed, collapsing not only into darkness, but into a crucible of unimaginable radiation. In such an environment, common molecular bonds fail, while exotic crystalline lattices, those rarely found in natural planetary chemistry, can emerge from the chaos. If 3I/Atlas was born there, then every ridge, every crystalline plate beneath its surface is a remnant of a stellar death throe. Simulations reconstruct a journey older than Earth's air. They imagine the object drifting through ionized shockwaves, carving through molecular clouds, and passing the gravitational grips of long-extinguished stars. Each encounter should have stripped it apart, shattering any fragile composition into dust. Yet 3I/Atlas survived, not merely intact, but with a geometry that suggests endurance far beyond the capabilities of standard cometary ice. This contradiction fuels a growing unease among planetary scientists. How does a body so delicate withstand forces that would pulverize even metallic asteroids? As researchers study its composition, the strangeness deepens. Embedded in the layers of the comet's shell are repeating crystalline patterns, swirling in slow spirals that maintain ratios too precise to be accidental. Natural processes can generate order, but not this level of stable, recursive geometry over billions of years. Even the shocks of interstellar travel, tidal distortions, radiation scarring, thermal shearing, should have erased such symmetry. And yet they remain, almost as if protected. This opens a quiet question in the scientific community. What if these patterns were not formed by nature alone? What if they were designed to endure the very violence that should have destroyed them? Some models test the idea of resonance stabilization, theoretical lattice structures capable of redirecting energy rather than absorbing it. Others propose that the comet once existed near the debris of an ancient technological event, where artificial compounds mixed with primordial ice. But these remain conjectures, reaching into speculative territories that science rarely treads. Still, the evidence invites the speculation. A structure this old should feel random, chaotic, scraped bare by time. Instead, 3I/Atlas feels curated. And if it was curated, then the curators have been gone for longer than complex life has existed on Earth. Across cosmic timescales, civilizations rise and vanish before their light crosses even a fraction of the galaxy. If something crafted or altered this comet in the deep past, its makers would be nothing more than dust scattered across ancient orbits. Yet their work survives, silently drifting until Curiosity's lens caught its glint above the Martian sky. What stories linger inside those crystalline layers? Stories shaped by stars that no longer shine. And if this relic endured the collapse of its birthplace, what other secrets might it still be carrying through the dark? 40 milliseconds. That is the interval during which Curiosity's camera, dust-coated and sun-worn, captured the clearest frame of 3I/Atlas as it slipped across the thin Martian sky. In that instant, too brief for the human eye, yet eternally preserved in digital memory, the interstellar traveler revealed a geometry unlike anything seen before. Humanity, watching from a distant blue world, suddenly faced a profound realization. Mars had become the stage for the clearest encounter with an object forged beyond the sun's domain. In laboratories across Earth, analysts pore over the repeating ridges carved into the comet's nucleus. Ridges that follow ratios as ancient as mathematics itself. Not golden spirals, nor Fibonacci echoes, but more elusive constants, irrational patterns that appear in coastlines, branching systems, and chaotic dynamic flows. Yet the precision of these structures lies beyond any tolerance expected of natural fractal formations. Under ordinary astrophysical conditions, thermal cycling and gravitational stress should blur such boundaries into random noise. But here, each ridge retains an uncanny consistency, as if the comet's surface were sculpted with intent or encoded with the density of ideas rather than the randomness of debris. Scientists hesitate to call information. The word suggests purpose, and purpose is something the scientific method approaches only with caution. Yet the suspicion lingers. If these patterns do carry meaning, then 3I/Atlas is not merely an object drifting from the galactic past. It is a vessel carrying whispers from an unknown epoch. The implications reach far beyond curiosity. For decades, interstellar visitors were considered unapproachable, appearing without warning and disappearing before any mission could reach them. But Curiosity's image changes everything. Suddenly, Mars becomes not only a world of ancient riverbeds and sedimentary secrets, but a vantage point for cosmic archaeology. Its thin atmosphere allows unparalleled clarity, Its stable surface provides the stillness no orbiting